This is naturally Stella, a student at Makerere University, offering bachelor's in software engineering, and I'm presenting a deployed product called Smart Mosquito Trap, whereby it was a group project with two other members, including Nakura Shadi and then Gloria. Moving forward, first of all, our product deals with the malaria vector, the malaria causing vector, which is the female Anopheles mosquito. So we've looked at the effects of malaria, how malaria has really affected Uganda as a whole over the years, because many methods have been carried out to combat the spread of malaria, but it has persisted over the decades, despite all the efforts in using insecticides, treated mosquito nets, indoor spreadings. All that has not been that effectful. So we've come up with our own way, or an AI-powered tool to help combat or stop the spread of malaria. So in our solution, first of all, we looked at the AI-powered detection, where we will use the machine learning. We use the machine learning to train models that can ably detect the mosquitoes which cause malaria, mainly by using their wing beat acoustic signatures in real time. And then we looked at the IoT sensor networks, mainly the IoT. These are interconnected low-cost nodes that work together to get the information or to track the position of the mosquito, to give feedback to the user of this system. Then we looked at the swarm coordination, whereby nodes communicate wirelessly to share detection, localize the mosquito. Mainly that's in the swarm coordination. And then if we are to look at the unique value of this tool we have implemented or we have put in place, so it will be able to provide real time, it will be scalable, sustainable, it will be safe for the environment mainly. And then here below I've presented the technology and the architecture we used. Mainly we trained models, the micro SCD net which we deployed because it had the best accuracy of the three models we trained. We trained the FNN model, we trained the GATT model, and we used the micro SCD because it had the best results. So the database, we used the Hamburg DB dataset to train our models. And in the Hamburg dataset, we had 4 folders of datasets, which included .wav files and other input datasets. So mainly that is the technology, and below is the architecture. The diagram, the flow diagram indicated here is our architecture of how our system will be working. In the business model, mainly here we look at the target users and the beneficiaries. Mainly our model or our smart mosquito trap will benefit the public health agencies, the local government, and other people, mainly in rural areas, because they are at they have a very high risk of facing the malaria vectors. So looking at the revenue streams here, we have the subscription model, whereby we have the subscription model whereby institutions pay for these services. And then we have the hardware sale of low-cost IoT sensor nodes and control units. Mainly, that's to deal with the business model, how our system will be operating. And then in the future plans are mainly we intend to add ISAF laser light to our system, mentorship and finding funds for our project. So our project will solicit for more funds to build, to improve on this project we are currently having. And then we shall have deployment in the different areas, mainly in the rural areas. Anyways, and then carrying out awareness events in different universities, schools. And this is the demo or our prototype. This is the point we are at this project. We came up with a mosquito classifier. We're able to build this, a deployed product of our smart mosquito trap. Here below on the right, you can see our mosquito classifier, whereby you can start recording and then you input a sound, and then it will be able to give you the prediction whether it's an anopheles mosquito or background noise or any other mosquito. So this is our system we built. Moving forward, finally, I would like to thank my groupmates with whom we carried out this project, and our dear lecturer for guiding us through this project. Thank you, my viewers. That's all I had for you. Thank you.